In order to understand similarity, we do need to first look at ratios. And as I said, I think you all will have seen ratios before, but we're just going to do a bit of a refresher. So what I often like to do in maths is take a mathematical idea and try to imagine it in a real life scenario that is familiar to me, because it makes it a lot easier for me to understand. So that's what I'm trying to do here. So let's imagine you're making 100 mils of liquid and you've got it split up as 2 parts red cordial, 3 parts water. We write this ratio as 2 to 3. Now, because it's the ratio 2 to 3, if you add those two numbers up, it tells you that there's 5 parts in total. So if you're dividing the total amount of liquid, 100, by 5 parts, you know that each part is worth 20 mils. If you want to know, if you're splitting 100 mils of liquid into 2 parts cordial, 3 parts water, you might want to know, well, how much cordial in mils and how much water in mils. So all we're going to do is work out how much one part is and then just multiply them. So we know 2 parts will be 2 times 20, so you get 40 mils of cordial. And if you have 3 parts water, you go 3 times 20, which is 60 mil. And it's a lot easier, we can see there from the visual as well. 40 mils red cordial, 60 mils water. More abstract example, just looking at line lengths. Ratios can also be used to see how many times bigger something is. So let's take the example of these lines here. Let's say that the blue line is 2.2 meters tall and the red line is 5.1 meters tall. So we can write the ratio of the length of the blue line through the length of the red line as 2.2 to 5.1. That's our ratio. However, as we actually did this in the CAT when we were looking at odds, so this part is likely going to be familiar to you. We often want to write ratios in the form of 1 to x, so 1 to some other number. What that's doing is saying how many times larger that second length is compared to the first one. To do this, what we do is divide each side of the ratio by the smaller number. In this case, the smaller number is 2.2. So if we look here, we had 2.2 to 5.1. And if we divide each side by the smaller number, it forces one of your numbers to become 1. Because obviously, if you divide a number by itself, you get 1. So this ratio simplified down to 1 to 2.32. Now, what that information is giving us, it tells us that the red line is 2.32 times larger than the blue line, or it's been expanded by a factor of 2.32. And often in ratios and similarity, this expansion factor will have the pronumeral k. So k is often used for the expansion factor. We say that the expansion factor between these two lines is 2.32. So the way I sort of like to think of it, you can sort of see it on a computer. You imagine you take this blue line, if you wanted to expand it 2.32 times, you're just sort of stretching it up. That's essentially what that expansion factor is. So we'll do a quick skill check. I'll set a timer for maybe 2 minutes if you guys want to have a crack at this one. So divide 9,000 into the ratio 2 to 7. So what I mean by similar to this example, we divided 100 into the ratio 2 to 3. And we worked out that 2 parts was 40 to 60. So do a similar thing with that one. And we've got a more worded question there. All right, let's look at this first one. So first thing we want to do First thing we want to do in order to do this is see how many parts we have in total. So we've got a ratio that's 2 to 7. So if we add those numbers up, we've got 9 parts in total. If we want to find out what does one part equal, well, one part will equal the total amount that we have, 9,000, divided by the total number of parts that we have. So one part is going to be 1,000. So that makes the calculation quite easy. So if we want to know what two parts is equal to, two parts will be 1,000 multiplied by 2. So two parts is worth 2,000. And 7 parts will be equal to 1,000 times 7. And we get 7,000. So dividing 9,000 into the ratio 2 to 7, we can write it as 2,000 to 7,000. That's our first one. The second one is quite similar to what we did. So what we're going to do is we've got a square that has a side length of 3, and the second square has a side length of 9. So we've got a ratio of 3 to 9.7. Now, if we want to find the expansion factor, because that's essentially what we're trying to do, we need to divide each side of this ratio by the smaller number. We're going to 3 over, not 2. We're going to have 3 over 3 to 9.7 over 3. And if we were to whack that in our calculator, we should have 3.23 if I'm keeping it to two significant figures. So 3.23 is our expansion factor, and that is how many times larger B is to A. So we can write it as, so B is 3.23 times larger than A. That's it. Now that we've refreshed ourselves on ratios, we can look at similarity. So in words, similarity is when all sides of a shape, it doesn't have to be a triangle, but often we do look at similar triangles. All sides of the shape are scaled up by the same factor and all the angles remain the same. So let's say if I was to scale this triangle up, just like that, what that means is, similar to we looked at the scale factor between these two lines, what you'd be doing is, if you took the scale factor between this side length and its corresponding side length there, it has to be the same scale factor as if you did it with this side length and this side length, and also the base length and this base length. So they've all been scaled up by the same factor amount. And importantly, all three of these angles are exactly the same. And sort of doing this, I mean, you can sort of see how that works. You know, that would be scaling it down. It's the same shape. It's just been enlarged or made smaller. So that's how we, 2 seconds, guys. The dogs are barking. So that's how we describe it in words, but we also want to know how to describe it mathematically. So all angles being equal, you might write it as A1 equals A2 equals A3 and so on if you have more than 3 angles. And for all the sides having the same expansion factor, this is how we can write it. So we've got this first triangle and it's bound by points A, B, and C. These points, and I should make a note, so when you've got an apostrophe, the way we sort of say this when you read it out to yourself in your head, that apostrophe is called prime. So I call this A prime, B prime, and C prime. So just keep that in mind. How we write this mathematically, we've got A prime, B prime. What this is referring to, on the top, it's just referring to this length that connects A prime and B prime. It's not multiplying A prime by B prime. I understand that might be confusing because you're used to, in algebra, there's sort of a hidden multiply there. But it's just referring to the side length that connects those 2 points. If you take this side length, A prime, B prime, and you divide it by the AB side length, that's going to give you the expansion factor between those two side lengths. And it needs to equal the expansion factor of this side length, A prime, C prime, divided by this side length, AC. And then so on, this side length divided by that side length. So that's all that's saying. It's just saying they're all expanded by the exact same factor. All right, so let's do an example. So I've left these notes here just so we can refer to them. We've got these two triangles which are similar. We've got triangle DAE, and it's similar to triangle BAC. And what we're trying to do is find this side length x. So we can actually, using the fact that they're similar, we can use this sort of idea to find x. So what we're going to do is, if I take the side length AC and I divide it by corresponding side length AE, that will give us the expansion factor of these two triangles. But because they're similar, I know the expansion factor actually needs to be the same. So if I take the side length AB, this longer side length AB, it needs to equal the side length, divide it by AD. Those two fractions are going to be the same amount. So once we've understood that, we can just insert the numbers that we know are here. So AC is a total length of 5 centimeters. See that? AE is a total length of 3 centimeters. That fraction has got to be equal to AB. This is where we're going to have to use some algebra. AB is 2 plus x. And then AD is just 2. So now we've got this sort of mathematical equation there, and we solve for x. So one way we can do that is, I want to get rid of this 2 at the bottom. It's going to be a little difficult while I'm typing it, but we'll give it the best crack I can. To get rid of this 2 on the bottom, I'm going to multiply this entire fraction by 2, and that will get rid of the 2. But I also need to multiply this entire fraction by 2. So what I end up with is that 2 at the bottom goes away. And if I'm multiplying this side by 2, the denominator gets multiplied by 2. So we've got 10 over 3 equals 2 plus x. Now all I need to do is subtract 2 side of the equation. If I subtract 2 from each side of the equation, this positive 2 and this negative 2 will cancel out. And I'm just left with x is equal to 10 over 3 minus 2. And if I pop that in my calculator, I end up with x is equal to, I get 4 over 3. So I can leave it as a fraction, or if you prefer a decimal, maybe 2 decimals, 1.33. So the key sort of steps here is using this sort of similarity idea to form an equation. You just got to use your sort of algebra skills to solve for the unknown value. A few different mathematical techniques going on there. It's a bit tricky. But I want to give you guys a chance to have a crack yourself. So we've got these two triangles which are similar. First thing I want you to do is try to find the expansion factor, k, and then use that to solve for this unknown value, x. What we're first going to do is, as we did in the last one, we're going to write our equation out. So because they're similar triangles, I'm going to start with the two sides we have. So I know what this side length is. It's 9 centimeters. And I know what this side length is. I've got A prime, B prime divided by AB. So that's going to be our scale factor to start with. And that's going to equal divided by 4. And when I put that in my calculator, I've got 2.25. Our scale factor of K is 2.25. Now that we know that, all we need to do is we just need to scale up 5 by this scale factor. So one way to do that is I've got my scale factor of 2.25, and I can just multiply it by this side length of 5, and that'll give me what this side length is. When I multiply that, I get 11.25 centimeters. Of course, you could have done it this way, where you sort of write both the fractions out. So in that case, you may have written, you did A prime B prime over AB, you had 9 over 4, and you may have just said that was equal to x over 5. So just making those two fractions equal each other. And when you solve for x, you would end up multiplying both sides by 5, which is essentially the same thing as this calculation. And you end up with 11.25. That's it. There is another example here. I'm going to go through it though.